Hi, everybody. It's Mr. Spengler. I'm glad to be with you again. Today's topic is condensation, and in order to kind of understand what's going on with condensation, it's interesting to look at what's happening to the particles that make up a substance. So right here, we're actually looking at neon gas, but it's not a gas right now. If you notice, it's holding its shape. Notice all these particles are moving. They're solid, the particles are moving, but they're not really going by each other, so that it's holding its shape. It's like an ice cube. Okay, what happens to the motion of the particles as I add heat? And feel free to go here. This is PhET phases of matter, or states of matter. Notice that the amount of movement has changed. Now we have a liquid. These particles can flow past each other, and if it gets warm enough, we'll have a liquid that'll fill the bottom of a container and take the shape of a container. If we continue heating, there's going to be more and more motion, and if we heat enough, there's going to be enough motion where those particles will fill the entire volume of the container, and we have ourselves a gas. So I'm going to skip to gas here. So gases have more movement than liquids, and liquids have more movement than solids. And remember, this movement is a measure of temperature. Average temperature of a substance is the average movement determines the temperature of a substance, is what I'm trying to say. So in order to make this gas into a liquid, I need to cool it. I need to slow down those particles so they start sticking together. So as you can see, they're starting to kind of clump together. Some of them are starting to sink. I wish this happened a little faster, but now notice that they're not really moving. So now we have a solid. Okay, so we've gone from a gas now to a, well, I guess this is a liquid here. And if I continue to cool it, yeah, there we have a solid. So just realize that we can change the material. It's still, in this case, neon. We can do this with water. So this would be an ice cube. And in liquid form, that would be liquid water. And this would be gaseous water. To go from solid to liquid to gas, we have to add energy and increase the movement of these particles. To do the opposite, to go from a gas to a liquid, watch what happens to the temperature. To go from a gas to a liquid, we have to cool it. The energy has to come out of here to the surroundings. And to go from a liquid to solid, once again, you have to cool it, and they're moving even less. Just keep that in mind during this activity. The activity we're going to do today is Amplify 1.3. We're going to do the warm-up. The warm-up simply has you, so you're going to stop this in a moment and answer these questions. Hey, what happens if it rains out and then that puddle that after the rain, how does it disappear? What happened? So write your thoughts here. Once again, don't spend too much time on it. Full sentences, you know the drill. Do a good job. Okay, but don't sweat it. It's not going to be graded other than for completion. Then you were supposed to do this in class, but of course we aren't able to do it. Um, I'm gonna set up an activity, okay? And the activity is relatively simple, and it's all about condensation. So if you can see here, I'm gonna see if I can make this bigger. It may work, it may not. It doesn't seem to be working. This one, okay, here we go. So this is a bag that I filled with air. I just blew it up like a balloon. And I did the same thing with another one, but I put that one in the freezer. Okay, and we're going to revisit that in a little bit. But here's one that's just sitting at room temperature. Remember, body temperature is 98.6. I blew into this bag. That's about 38 degrees Celsius. So this parcel of air was 38 degrees Celsius, but my house is probably 21 degrees Celsius. So there is a tad bit of condensation. You can see the cloudiness in the bag. We're going to compare this to the one that I put in the freezer when we get there. So that's the lab you were supposed to set up. See if I can adjust this. Yeah, there we go. So just remember, air parcel is a chunk of air that moves as a unit. So this cloud is in an air parcel that's moved up and cooled. And that's what this box represents. You're going to see that box in the sim in just a moment. I'm going to click next. Okay, so here's the two bags. I put one just on my tabletop, and the other one I put in the freezer. Okay, and we'll get to those in just a little bit. Now we're going to simulate what we just did with the bags, or what I just did with the bags. And we're going to simulate it in a simulator. But before we do that, we want to have you predict what's going to happen. So we're going to have two situations where that air is in a parcel that's surrounded by warm air versus one that's surrounded by cold air. Which one do you think will have more condensation in it? The one at room temperature or the one that's in the cooler? And ditto on this one. What do you think will have the greatest amount of energy transfer? Don't worry about that too much. It's just get you thinking before the activity. And now go to the weather sim. Here's the link. Okay, and it's a little slow coming up. And here we go. So it tells us just how to set this up. So if you're gonna have to bounce between screens here, but it says this first one where the surrounding air temperature is 20. This represents the room temperature one because 20 is room temperature. 37 degrees is body temperature. Okay, so we're going to set this up 20 and 37, and water vapor between medium and high, 20 and 37. So we'll back to the sim, 20 and 37. So the air parcel is supposed to be 37. So you're going to set this up and put it at 20. So think about this. If this is a body of air and it's surrounded by air that's cooler than it, what's going to happen to that energy? Well, let's see. Let's hit run and watch what happens. So I'm going to kind of rewind that and take a look at it. All right, so what happened? Well, taking a look, let me zoom this backward here. All right, so what happened is initially it was at 36 degrees Celsius, okay, but watch that temperature change. See how it's dropping? And it's dropping because its energy is going to the surrounding air. The surrounding air, there's so much of it, it's not changing in temperature, but it continued to happen until the temperatures evened out, and then that's it. It's done changing. So if we look over at this analysis on the side, there's energy that's been transmitted out, and it's 15 megajoules, 15 million joules. So I'll record that in my space here. Okay, so it was 15 megajoules. The liquid water, I'll look at that real quick. The liquid water is 0, and this is 0. It's all water vapor. So I go back to here, and I put 0, 0, and 0. You're going to set it up for the next one, okay, and do it and fill out your findings. Okay, so it says which test had more condensation and which one. That's what you're going to have to see after doing the next one. And once you fill these out, save and continue. Nothing really to do there. Nothing to do there. Things we've covered, so that's good. All right. So now we're going to go back to the hands-on activity. So I'll be right back. So here we are again. I'll make it a little bigger so you can see. All right, so here's the bag I was showing you earlier. Okay, there's a little bit of condensation. That's why it's kind of cloudy, because it was my breath, and it's a little cooler in the air around me. And then here's the one, And this isn't ideal, but I don't know if you can see it. There's all sorts of spots on here, and those spots are ice crystals. So water condensed on the outside. I don't know if you can see that there. It's just a matter of getting to the right. Yeah, you can see it there. There's quite a bit more condensation on this one than in this one. Just looking at the colors from a distance, you can tell this one is much cloudier than this one. Okay, so there was condensation in here because my breath basically condensed on the inside of this bag. Moving on. So it says to discuss with your group, but you don't have to do with your group, but just realize that the one that was in the cool condensed. And on to the next activity. Just answer this question on the homework. What happened when you see this condensation on a window? All right, and that's it for this week's activity. Make sure to go ahead and read this gravity activity as well, and answer these couple of questions. It's nothing too tough. It's kind of some simple stuff on gravity, and hopefully it brings things together. But that's it for this week. Looking forward to learning with you again next week. So hang tight. Bye.